This is Hulk. Hulk is very good at smashing, but he can't do anything else. Then there is Tony Stark. Tony is very smart. He invented the Iron Man suit in a cave using scrap tools. He created a source of infinite green energy and saved himself from dying. He learned how to be better and improve himself. He can fight too, and if Tony wanted to beat Hulk, he could do that too. What does this have to do with AGI? These two represent AI and AGI. Hulk represents the narrow AI, or let's call it just AI. He's very good at one thing, which is smashing. For a real example, take a look at DALL-E 3. It only can draw pictures and create images, but it can't solve math. Or GPT-4, it can solve math, but it can't draw images. Or Sora, the new text-to-video AI. It can turn images to video, but it can't produce audio. We call that narrow AI. It's an AI created and trained to do one thing and to be very good at it. But no matter how it try, it can't be good at anything else unless we make it and train it to do that too. The benchmark of narrow AI is based on how good it is at doing what it's created for. But Tony, who represents the AGI, short for Artificial General Intelligence, is good at so many things because he's very smart. The main reason for that he can learn by himself and do so many things without being trained on them. If he wanted to solve math, he will learn how to solve math and actually be able to do that. If he wanted to drive cars, he will learn how to drive cars. If he wanted to go to space, he will learn how to do that also. The options for him are limitless, and we don't have to train him on them. When it's come to AGI, the human intelligence itself is the benchmark. AGI, also referred as strong AI or full AI. It's a concept for machine with ability to understand and learn and apply knowledge in a way as the human being do. Unlike narrow AI or weak AI, which is designed to perform specific tasks such as image recognition or playing chess, AGI will have the ability to do more abilities like learning and reasoning. AGI could learn from experience and understand complex ideas and figure things out, like how to solve a puzzle, for example. It will have the ability to transfer learning. AGI could learn language and then use this knowledge to help them to learn another language or completely different skill. It will also have adaptability and flexibility. If things change, AGI could adapt and handle new situations, unlike today AI, which can get stuck if things aren't exactly how it's expected, and it's limited only on the data that's trained on. It also have autonomy, which basically means it works on its own. AGI wouldn't need constant instruction. It could make its own decision based on what it have been learning before. And maybe it will be even slightly self-aware or conscious. Some scientists believe that AGI might be aware of itself, but this is a complex idea that is still being in a debate. I can't explain exactly how to build AGI yet. It's like a giant piece of puzzle with many pieces. Here is the breakdown of some of the main key pieces the researchers are using to create this technology. The first piece is deep learning and machine learning. This will let the AI to find patterns in huge amount of data like text, picture, or video, when we're already seeing that in the current AI models that we have. The second piece is generative AI. This builds on the deep learning to create new things, like writing homework or writing story. Third part is natural language processing, or short for it, NLP. This translates between computer code and the human language. Computer doesn't understand the human language, it transfers it to numbers and use this number to basically create for us the output. And NLP helps them to understand what we say. These three pieces are already used in Gemini and GPT and Mistral models and all the current AI models that we have. The other part are computer vision. This is how the AGI will be able to see the world and it will be able to recognize objects and even track them. For example, like self-driving cars right now, it can spot people on the road and avoid them. The last piece of this puzzle is robotics. This is basically will build and gives the AGI a physical body in the real world. These are just some of the pieces of the AGI puzzle. The funny part is, if you go right now and ask GPT-4 about it, it will mention that OpenAI and DeepMind are the current driving force that's trying to achieve AGI, which is kinda lead us to what's happening to these days. It seems like every single tech YouTuber right now is either talking about it or mentioning that OpenAI is so close to achieve AGI. And that's even before Elon Musk sued both OpenAI and the CEO for turning the company from non-profit open source company to a closed source money-making company that's work for its sugar daddy, Microsoft. There was a whistleblower named Jimmy Apples who tweeted a few months ago that OpenAI achieved AGI internally. And we will have AGI before the end of 2025, but we don't have a valid statement from them yet at all. I find it very weird when right now we have three models that beaten up GPT-4 to the ground, Claudia and Mistral Large and Gemini 1.5, and OpenAI like months ago announced they are switching their focus to autonomous AI agents. It's kinda odd, especially with the rumors that saying that they achieved AGI internally. Agent is kinda the closest thing that we got to a baby AGI few months back. We can't tell exactly what will happen when we have AGI for real. Might solve world hunger, cure cancer, or create a printer that doesn't jam, or find a way to travel space much faster. Right now, we don't know. But right now, we know that AI will change the world. We have just to learn how to use it and keep up with it. Actually, this idea of a smart machine or AGI isn't new at all. From 40s to 50s, scientists like Alan Turing started to think about how to build the machines that could think and act like humans. They even came up with a test called the Turing test to see if a machine could fool someone into thinking it was a real person having a conversation. Back then, computers weren't powerful enough to handle complex tasks like right now, so the progress was super slow. But there was still some bright spots, like development in understanding human language. By the late 70s, the AI research had grown up quite a bit. In the 80s, it saw a big boom with the new systems that could learn and solve problems in specific areas. Then came the AI winter. This period was like a cold spell for the AI research. People lost interest because the early AI projects were too expensive and not that impressive. Then came the AI agents. From 93 to 2011, things started to heat up again. AI made some big breakthrough. Like AI was able to beat the world chess champion and the creation of a robot vacuum cleaner that could clean your house. This reignited the interest in AI once more, and more people put more money in research, which leads us to the current era that we are right now in. From 2012 to the present day, AI right now is almost everywhere. It's in YouTube, search engine, a voice assistant, it's even in a video game characters. This era is about making AI more powerful and versatile. Researchers trying to create an AI that can understand the world as well as the human do, like how a child can learn from experience. And in the end, I want to thank you for watching this video. I hope that you learned something new from this video. My name is Husamuddin, or you can simply call me Sam. Please hit the subscribe and notification like button. It will help my channel a lot. And I'm gonna make more videos like this. This is not a promise. This is actually a threat. And see you in the next video.